So far, we have been looking at public fields, and our examples have been pretty simple. And in reality, the fields are typically private. And sometimes, if you have a base class or if you're creating a class that you think uh, others will derive new classes from, you may make the access modifier protected. So we're going to talk a little bit about the different access modifiers and how they affect access to the fields in the derived class. So you all know that public fields and public methods can be accessed by any class anywhere. Uh, Private fields have to be accessed through get and set methods. And that is true if you derive a new class from an existing base and the base has private fields. You're still going to have to call those get and set methods. There is a third level of accessibility called protected. And what protected does is if you have a base and you have derived a new class, if a field is protected, the new class, the derived class, has access to it without using get and set methods. And so that is an advantage of using protected if you are planning on having the class act as a base. Anything that's outside of the class, any other class that's not derived, does not have access to the field and would have to use get and set methods. So I am going to show you an example so you can kind of see how this works, but I just want to quick summarize. So if we're dealing with inheritance, if the field or method is public, it remains public in the inherited class. So pretty much anyone has access to the fields or the methods, regardless of what class they're in. Okay. If anything is private in the base, then you have to access it through get and set methods in the inherited class. Okay. And anything that is protected in the base, you can directly access through the inherited class and you don't have to use the get and set methods. So to exemplify all of this, I did create an example using our now infamous animal class. We have 3 fields and each one has a different access modifier. So for name, I used private. Protected is type, and public access is color. Now, for name, because it's private, there is a set name and a get name method. For type, I also created a set type and a get type method, even though a derived class would not need to use them. Any other class that wanted to set a value for type would have to use set type and get type. Okay, so for a derived class from animal, no, they would not need to use the methods, but any other class would. Okay, so if you use protected, you still need to do the get and the set type methods in your class. For color, that is public. And so I don't really need any get or set methods because everyone has access to it. Then I've got my little derived class here. And you can see I've created 2 additional fields. One is public and one is protected. Breed is public and age is protected. So breed, I did not do a get or set for, but I did do it for age because If there is no derived class, any other class is going to have to use the get and the set. Then you'll notice that for the other methods, I did create an override method for name. And if you remember, up here, name is private. So, and I could do the override because I made it virtual. For name, you'll notice because it's private, I can't directly access name here. So I have to use base.getName to retrieve the value. Okay. And then for type, because type is protected, and this is a derived class, I do not need to use the getType method. I can access type directly, and that is only because dog is derived from animal. Okay, and then here I've got another method for dog that's unique to the dog class. And you'll notice with both getName and getType, because they are in the base, I did override them. So how are we going to populate all of these fields with data? I'm creating a animal object I call critter. For name, which is private, I'm using setName. Because I am now in a different class, I'm in a program class, this is not derived, to put a value into type, I have to use setType, okay, because it's protected. Okay, and then for color, it's public, so I can directly access color and put a value into it. As far as retrieving the data, it's very similar. Because name is private, I have to use getName. Because type is protected and I'm not in a derived class, I have to use getType. And critter is public, so I can access that directly. Then we come down here to dog. And so I'm creating a new dog object. And you'll see it's very similar. I've got setName, setType. I have to call the methods because name is private, even though type is protected and the dog class has access to it. I am in a different class. I am in a program class, so I still have to call setType. Color is public, so I can directly access that. Breed is public, so I can directly access that. And age was protected. So I still have to call setAge because I am in the program class, which does not have direct access to age. Then to retrieve the data, I'm using getName for the private field. For breed, which is public, I can access that directly. For type, which is protected, I have to use getType. Color is public. GetAge is accessing age, which is protected. And puppy.sound is just a method I'm calling. Okay, so you can actually copy this and paste it, and you can run it and kind of see how it works. All right, so I've got another example, and this is probably a little bit more realistic because all of the base fields are private. So all of the base fields are going to require get and set methods. There really is no difference in how the default and parameterized constructors operate. It doesn't really matter private, public, they all kind of work the same. But you can see I've got get and set methods for every single field because they are private. And instead of doing the longer vertical format, I used a shorter horizontal format because this is a rather lengthy program. But it basically works the same way that we've been looking at. So moving on here, I did create a couple virtual methods. I've got an add change. So if the user wants to add or change the data, they are prompted for each piece of data, and then the piece is read in from the console, and you can see that it is passed on to the set method here, set ID. Here it's passed on to set first name, set last name, and set age. So inside I've got the console.readline, and it's passing that data to the appropriate set method, which is then placing the value into the field. And for the print, I'm using the get methods to retrieve the data. And I've kind of got it formatted how I want. And you'll notice these are virtual, which means they can be overridden. So I've got my manager class that is derived from employees. I've got a couple more private fields. And so you can see there is no difference in how we're handling the inheritance here. We are, for the default constructor, calling the base, and we're only worrying about initializing our new fields. And for the parameterized constructor, we're passing along the data that the base needs. And then we are initializing the two fields that we created in Manager. Okay, so I'm going to kind of emphasize here that the parameterized constructor needs all of the data for the derived class and the base. And the base information is passed along without the data types. So here I've got all of the data types, okay, in my method signature, but when I pass along to the base, it is just the variable names that I'm passing. I've got get and set methods for the two fields that I've created in Manager, and I am overriding the add change and I'm overriding the print. To get the data into the private fields that are in the base, I am calling the base add change. So it'll go up and run through this, and then it'll come back here and run through the prompt and the set methods for my manager class. And it does the same thing for print. I'm calling the base print. So it's going to run through this, and then it's going to come back down here and run through the rest of this code. Okay, so those are my two classes. And the main program is a lot lengthier because I'm going to allow the user to add data, change data, and print data. And I'm going to allow them to do it for an employee or a manager. And so I'm prompting them, how many employees do you want to enter? And I declare a little variable here. I read it in and make sure it's a number. And as long as it's a number, I output the value in max emps. And then I use that value to create an employee object array. So the object array is called emps. Okay. And then I do the same thing for managers. How many managers you want to enter? Create a little max manager value. I ensure that it's a number. As long as it's a number, it gets output as max manager. And then I create an array of manager objects. Okay? And I've kind of abbreviated it MGR. Okay, so at this point, I have an array of employee objects and I have an array of manager objects. And by default, C# sets all of the values to null. Okay, and that is an important thing to remember. Then I'm declaring some additional variables. I've got choice, record, and type. And then I've got an employee counter and a manager counter so that I can keep track of how many items I've entered in each of the arrays. Then I call a menu method to retrieve their choice. So that is down here. And please make a selection from the menu. One is add, 2 is change, 3 is print, 4 is quit. Okay, and so I kind of verify that they have entered the proper number. Okay, and then I've also verified that it is a number. And as long as they have entered a number that is between 1 and 4, it is going to put that number in selection. And selection is what gets returned. So it gets returned up here in choice. So as long as they didn't do a 4, I'm going to stay in my while loop. And the next thing I need to know is, do you want to enter a manager information or employee? Okay, which one? And so again, I'm verifying that they enter a number. And then you might say, well, you're not making sure they do a 1 or a 2. And that's probably because I have a switch. So there's a default case where it tells them, to try again. So I'm not as concerned here with enforcing the 1 or 2 because I'm going to catch it in the switch. And you'll notice that I did do a try and catch here. And so here in my switch, if they did a 1, that means they want to add. So here is where they put in the type. Okay, and the type should be a 1 or a 2. If it's a 1, that means they want to add. And if their choice was a 1, they're adding. And if the type is a 1, it's manager. Okay, so, and I've got these comments in here so you can kind of follow along. So if they, in the menu, they picked add and then they chose manager, it's going to run through this code. If they chose anything else, and this is how I'm handling other numbers besides if they did like a 3 or a 4, guess what? You get to enter an employee. So 1 is always manager, anything else is employee. So here, we're going to add a manager. So first, we're going to check to make sure that we haven't exceeded the maximum number. And as long as we haven't exceeded the maximum number, we are going to take the current location in the array and we are putting a manager object into that location, which replaces the null value. Okay, and you have to do that if you have an array of objects. Otherwise, you're not going to be able to add anything. So once we have the manager data in that location in the array, and here it's just going to use the default constructor. So basically, what it's doing right there is we're getting the location and salary, and plus it's running through here. So it's just initializing everything. Okay, then we are going to take that object and call add change. Okay, so this is a manager object that is calling add change. So it's going to run through this one. So it's going to call the base. We're going to get all of these prompts from the base, and then it's going to prompt us for the additional manager information. And then we add 1 to the counter. Okay. If for some reason we exceeded the limit, so we said we're going to do 3 managers and we try to enter 4, okay, then it's just going to display a message that, you've already reached the maximum. Okay. If we chose add in the menu, and then at this prompt for type, we picked anything besides a 1, okay, it's going to come down here for employee. And it's going to do the same thing. It's going to check to see if we have reached our limit. And as long as we have not reached the limit, it's going to take that element in the array and it's going to set that to a new employee, which replaces the null value that was there. Okay, and then once we have the fields, okay, we can call the add change. This is going to go through the employee add change, and it's going to populate those fields with data. And then it's going to add 1 to the counter. And if we exceeded the limit of employees, if we said we wanted to add 10 employees and we're trying to add an 11th one, then it's going to give them this little message. Okay, and at that point, it would be done. It would break out of case 1. Okay, and we did not have an exception. Okay, so we pop over all the catch and we display the menu again. So they get the menu. Let's say they choose a 2 this time. Okay, so we go back up here. Well, it's not a 4. So then we get the prompt for the type. And so if they choose a 1, we get into our switch. They wanted to run through case 2, which is change. Then we have to enter the record number they want to change. Here we're making sure it is a number. And then we are subtracting 1. And that is because the array starts at 0. So if people put in they wanted to change record 2, well, when we're indexing in, we're going to index in with a 1 because 0 is the first one and 1 is the second one. So this kind of adjusts that index number. And then we're checking if they wanted manager or employee, which one they're going to change. And then we do need to verify that the number that they are going to try to index with is valid, right? If it is greater than our counter, -1, or if it's less than 0, we got a problem because they're trying to access an element that is outside the bounds of what we've entered. Okay, and so we're displaying the message that the value is out of range, and we are going to have them read it in again. Now, you might be thinking, why didn't I just throw an exception? Well, I want them to be able to stay in the program, and if I throw an exception, it actually takes them out of this loop. Like it'll go in here, but that's not necessarily what I want. So I do want them, if they said they wanted to change something, I do want them to pick a valid number. Okay, and once they get a valid number, then it is going to call add change. It's going to subscript into my manager object array and call add change, and it will allow them to change that element's data. So add change again is going to run through here. And employee works similar. So when we get down here, we know that rec is an actual number, it's a valid number, but we don't know if it's in the right range. So we check to see if it's greater than the counter -1, it's a problem because it's outside the bounds of our array. And if it's less than 0, it's a problem. So we basically make them enter a valid number, and we adjust it for starting at 0. So it's going to stay in here until they've actually given us a number that exists within our array. And then we call add change using rec to subscript in or index in. Okay, and then we've got the break, which takes us all the way down to here, and we display the menu again. So our last case involves printing. And so with printing, if they chose a 3 in the menu, and then they said they wanted the type manager, you will notice that I've got a little for loop here. And you may think, why didn't I use a for each? Because I am only going to print as many objects as I have entered. So you can see I've got the counter here. So if I said I was going to enter 10 managers and I only entered 2, I only want to print out 2. Okay, and so that is why I'm using a for loop. And same reason exists for the employee. I'm using emp counter because I only want to print the employees that I've actually entered. Okay, and then the default for the switch, if you remember, the switch is switching on the menu choice. This is going to be if they keyed in a bad number. So it's not, 1, 2, 3, or 4. They made a mistake. And so it's just going to basically tell them to try again. And the break is going to take them back down to the menu. Okay, so that is what is going on in this program. Now, what if we changed the base fields and the manager fields to protected? Well, technically, if I did that, and I knew that there was no other classes that were going to access this data, okay, I could conceivably get rid of all my get and sets. Okay, I could have my add, change, and print. I could do the same thing here. And now that it's protected, I can actually access everything from the base here. And I can access everything from the base here. And that would be my class. Okay, everything else is the same. It does not affect the main method whatsoever. The main method was not trying to access any of the fields. Okay, it was using add, change, and print. And so changing this to protected basically changed what I was doing in the add, change, and the print. Because now I can access all of those base fields, whereas before I could have, but I was using the get and set instead. So technically, what I could have done here, and this would have worked as well. Let me copy this and show you. Okay, so I just wanted to show you different ways of setting this up. Let me pull this over. So here it is. All right, so I changed these all to protected. And the way I have set this up, I could keep my gets and sets. Okay, if I thought another class outside of employees would want to access those fields, it would make sense to keep them. Okay. And I could do the same thing here. I could keep the gets and sets. I wouldn't have to change a thing. I could keep everything else the same and it would run fine. How many employees? We'll do 10. How many managers? 3. Make a change from the menu or make a selection. We'll do an add. Let's add a manager. Age. How old is Fred? Location. All right, let's take a look at Fred's information. We'll do a print on him. Manager. All right, that looks good. And so you can see that it works the same. This is exactly how it works with private. Okay. Um, so if you're wondering what the benefit is of using protected, it is the ability to do this, to not be forced to use get and set. So let me take this. Put this in here. So I'm going to replace this. Oops, we don't want to replace our program though. Okay. So now I've got the modified base and derived class, and I'm going to run this. And you'll notice there is no difference in how the main method is processing things. It's going to look the exact same. Oops. Probably have to do a change now. All right, I'll go ahead and do a change. Let's see, we're going to change the manager. It's record number 1. And so we'll try this again. We'll give him more money. All right, let's print it. Okay. And you can see I did it kind of adjust the printout on this just because I could. And then if we wanted to add, let's add an employee. Let's see. And let's print her. All right. So hopefully these examples help you understand uh, the difference between deriving a class using public fields versus private fields versus protected fields.